Okay, I want to share an interesting example on creative thinking. See, everyone is creative. The point is, how can you apply it in a context of a problem consistently over a period of time? One of the biggest challenge each one of us experience is something called inertia. Yeah, we all know inertia. I'm inertia at rest. I'm sitting out there. But there's something called psychological inertia, the inertia to think, the inertia to think clearly, creatively. The learning what I'm talking about is a learning which evolved over 7 decades, as I mentioned earlier. It all started from understanding patterns, understanding patterns of pattern, understanding how someone can decode inventions and come with a very structured method that can actually make anyone who goes through the flow of problem solving, they can actually come with quite novel solutions. What this method talks about is someone has already solved a problem, the problem that you are experiencing or I am experiencing, but that's in a different domain. The fact that the smartness is to adapt a solution from totally a different domain and getting into our domain. How do you do that? If it has been so easy, people have done it. So there are a lot of low-hanging fruits in every situation. People who do that, you would see inventions coming from totally one domain to another domain. For example, if you have seen the color of skin plays a significant role in one's life. It's an under psyche problem across the world. So if you look at someone trying to come with a cream, temporarily you're talking about your texture, you're not talking about changing your color permanently, it's only a temporary one. So how you can actually come with a solution that's more practically applied, but that's something quite from different domains, which is very well proven. It would be quite surprising to know that some of the animals in the polar region look to be always in white color. I'm sure some of them come to your mind, but one of the examples which I would like to take is a polar bear. What do you think is the skin color of polar bear? Someone who guessed it would be white. It's charcoal black. Okay. What is its fur then? It's not white. It's optic fiber. A translucent material on a dark substrate here looks very white. Now, the people who are in the business of making creams, they adapted it. A polar bear didn't patent it. But if you look at it, this methodology gives you an ability to go to domains that are totally beyond our regular work. Adapt solutions. Obviously, you formulate problems. You formulate inventive problems. An inventive problem is one which has two conflicting requirements. You would have seen kids playing seesaw game, right? So someone would go up at an expense of someone. This win, this lose. That's traditional design. So the best known method is, chalo 50-50 karenge. But now what we are talking about is, can we come with an approach of a solution where these two guys hang on at the top at the same time, a win-win. That's the method that we teach and we apply it, really. So just to put that in perspective, what I thought is I'll give a very interesting example in this way. And it's all about problems. It's all about inventive problems. Let's say there's no one in this world who can't live without this. Let's say I want this mobile phone to be as big as this. Why? I want to say big image. I want to experience it. But what's the problem? It's very difficult. It's not convenient to carry. But the other problem is I lose my privacy. That's a win-win. It's a win-lose problem. You see the best models out in the world.